All right, so today we're going to be going through basically two different topics because each one is fairly short and straightforward. The first one is graphing cubics, which is why you have your two graphing grids set up. And so you'll notice that this is a cubic function because it's x cubed. This is going to be a new parent function of the cubic function. And so this graph that you make for this very first one is going to be the one that you can then reference back anytime I tell you graph a cubic. All right, so normally if I were making a totally new graph, and yes, this one's a totally new one. Most of the graphs we've seen so far this year have been a repeat of something in some way. This one's totally new for you. So whenever we make a new one, a great way to start is by making a table of values like x and y. And we're kind of going to do that as we go here. Just, I'm not going to actually draw out the table for every one of these, as you'll see. But, you know, the idea behind it is that I pick some x value, like 0, and I say, what would the y value be? So I take that 0 and I plug it in for x up here. So that means y equals 0 cubed. What is 0 cubed? 0. And so then if x is 0, y is 0. What that tells me is that I now have the coordinates of a point that I can plot here at 0, 0. So go ahead and plot that point at 0, 0. Make it big and easy to see and easy to recognize that that is there, because that's your starting point. All right, now that we have that point, we think about what would I do next if I were making a table. Well, the next thing I'd do is grab another number, and I'm going to grab x equals 1 as my next number. So that means I'm going to be doing y equals 1 cubed. So if x is 1, what is y? 1. Because 1 times 1 times 1 is 1. And so we plot the point at 1, 1. So notice, from our starting point then, I went over 1 and up 1. That's certainly been a very familiar pattern, right? So many of our graphs have done exactly that. But where we go from there, of course, does change. So then, what if we go over 2? If x is 2, what is y? That means we're doing 2 cubed, which when we look at it, a lot of people want to say 6 because we see the 2 next to the 3, so we think multiplying, but no, it is 2 times 2 times 2, because 2 cubed. And so yes, that's why it was 8, as I heard many of you say. And so we plot that point next, that is over 2 and up 8. All right, so at this point then, I can know then what's kind of happening over here on the right side, where I'm seeing this kind of a thing happening on the graph. Can I fit any more points in on the right side? Doesn't look likely, but let's actually check. What if I went out to x equals 3 here? What's 3 cubed? 27. Yep. That's definitely off my graphing grid. Probably off yours as well, so that's why we don't need to plot that one. But we do now need to figure out what's going on the left side, because we can't just assume that it's going to do the same thing on the left side like that. Because there are different types of graphs you'll see. Some of them will bounce up, like the quadratic we saw already this year. There's actually graphs that will just level out, and graphs that will kind of flip and go the other way. So we need to be able to figure out which one of these is, and so that of course means going ahead and grabbing another point. So I'm going to look and see what's happening when x equals negative 1. So if x equals negative 1, what does y equal? Well, in this one, people tend to be a little bit less confident, so I just want to make sure that we see why this is. Negative 1 cubed, of course, means negative 1 times itself 3 times. If I'm going to multiply 3 things together, I have to multiply the first 2 together first. So negative 1 times negative 1 is 1, positive 1. So I'm doing 1 times negative 1. And 1 times negative 1, of course, is negative 1. So you notice that when I did a negative number cubed, I did get a negative number out. When I did a negative number squared, I always got a positive. What's the difference? It's all about the exponent. If that exponent is even, it'll always give you a positive number out. If your exponent is odd, a negative number in is a negative number out. All right, so we saw that we went to negative 1, negative 1. I can plot that point. If I go to negative 2, where are we going to go? Yep, negative 8. reason. And we have those points. Now don't draw your curve through quite yet. I want to talk about what it's going to look like. I don't want you rushing ahead on that part. Because our natural assumption when drawing in the curve is that the first thing our eyes see is these 3 points close together. And so we really want to kind of start by doing that. And so we end up with a graph that does this, which is kind of good, but kind of not. It's going through the right points, and it has the right general shape, but there's some subtleties that are off here. Because if you were to look really close at what's happening here as we get close to 0, what you'd be finding is that, like if you do 1/2 to the 3rd power, it gives you 1/8. It doesn't go up very far. And so as we get close to 0, you're actually seeing it get flatter and flatter. This graph actually flattens out at 0 before turning and doing the same thing going down. So notice that right around 0, we need it basically horizontal. So when you go and draw on this curve, you might even want to start there of drawing that little horizontal bit in, and then you can worry about drawing the rest of the graph in that goes around it. But do make sure that it is flattening out at 0, at that starting point. And so then this is our graph. So go ahead and draw that curve in now. And yes, do extend the graph out to the edges of your graphing grid. Don't just stop at the points. Now this, of course, was a cubic function. This was a cubic function without any other transformations in it. And so then this is our parent function. Every single time now that you see a graph you need to make that has something cubed, you know that it goes back to this graph. And so how do we know the rest of it? Does it follow all the same rules that we saw earlier this year, things like that? The answer is yes. Which means that I can throw an equation like this at you, and you can actually graph this then, because you know what the cubed graph looks like. And from the work we did earlier this year, you know what the -4 does, and you know what the -1 does. So, with that in mind, write this equation above your second graphing grid, and then go ahead and make the graph, please. All right, so when making this graph, it does follow all the same rules. So the -4 that's inside the parentheses, it's inside with x, so it moves it in the x direction. And just like we saw with all of our other graphs, a minus moves it to the right. That's the one that's always kind of opposite. All right, then the -1 hanging on the end. That is our shift up and down. A minus there is not opposite. The minus there will go down. So the very first thing we're going to do is we're going to go right 4 and down 1 and plot a point right there. That is our starting point. That is the all-important point. So now, once we've done that point, we now just go back to our parent function and put in all the same points, just starting at that point instead of starting at 0, 0. And so I go over 1 and up 1, and I go over 2, and I go up 8. And I'm going to do the same thing on both sides. So now on the left side, I'm going to go left 1 and down 1, and then I'm going to go left 1 and down 8. Make sure that you're counting by 8, not just going to 8, which can be a temptation on a graph like this. And then once you've drawn those, you can go ahead and draw your graph in through them. And so then this is what we are working for. This is our graph that we wanted to get out of it. And you can get the same thing even without the transformations in there too. Like, what if I put a 2 out front of the parentheses? Could we graph that? Yeah. You remember that the 2 multiplied out front is our vertical stretch, so that would be saying, oh, well, we'd go up 2 instead of up 1. And we'd go up 16 instead of up 8. That sort of thing. Or what if I had a negative out front of the parentheses? We remember what that would do, right? Because the negative out front with our quadratics, instead of making it open up, the negative made it open down. It'd do the same thing here. It'd flip it upside down. So instead of going up on the right, it would go down on the right side. And instead of going down on the left, it would go up on the left. And so you'd end up with a graph that looks more like that. But the patterns are all the same. We're still going 1, 1 and 2, 8. We're still cubing all the numbers. And so all those same rules that you knew from before, they still hold. One other tiny little detail that's probably worth mentioning, this point here where we started, I've just been calling it the starting point. We would not call it a vertex. That's one thing that's a little bit more unique to the quadratic and some graphs that look like that. This is not actually a vertex here. If you want to be extra fancy, you can call it a point of inflection, but I'm not expecting you to know that. Starting point's just fine for our purposes here. All right, so this is all we're doing with our cubic functions. I think now you got the idea about how to graph them. I said we're covering two little topics today. So the other one's more algebraic. So you can either do these problems on your graph paper or separate line paper as you wish. Please start by writing down this problem. And you'll notice that what's different about this compared to other problems we've done is that in this problem we're being asked to multiply 3 binomials. In the past, we've done this sort of problem where we only had 2 binomials. We've done those. But we've never had to throw in the third binomial. So we have to be able to see how do we deal with that situation. So there's lots of little misconceptions that can come up. I've seen a lot of people where they like try to multiply this into those and then this into all of them, and it gets a little messy, but it actually just doesn't even work anyway. So let me take you back, get through any misconceptions that you might have with a much simpler problem. What if I gave you 2 times 3 times 4? What does that equal? 24. Now, when you did that problem in your head, did you do 2 times 3 times 4 all simultaneously? Or did you do 2 times 3 and then multiplied that answer by 4? You really started by doing the 2 times 3, right? You didn't multiply the 2 to both the 3 and the 4 or anything like that because they're all being multiplied. We can just multiply them in order as we see them. The same thing is going to be true here. And so in order to be able to do this problem, I'm just going to pick 2 of them, and I'm going to multiply those 2 together. And then once I've done that, then I can worry about the third number, or in this case, the third binomial. So please go ahead and multiply the x minus 2 by the x minus 10. All right, now just to make sure we got this process down, remember that in order to multiply these through, I'm going to be multiplying everything in the first parentheses by everything in the second parentheses. Now, when you do that, notice it's a negative 2, so that gives me negative 2x, and then negative 2 and negative 10 gives me a positive 20. And so that takes care of multiplying just those first 2 sets of parentheses. But notice that I still have this x minus 3 there. And so I still have to write that x minus 3 on the end. The problem can come into worrying about little details about how we've done this. Because while I've done all of my work correctly up to this point, it's technically not right at the moment. Because with how this is written right now, what is being multiplied by the x minus 3? Yeah, only the 20. But it shouldn't just be the 20. Because remember, this whole thing up here is what was being multiplied by the x minus 3. So after you multiply that out, put parentheses around that so that the whole thing is multiplying by x minus 3. And so now, having gotten to this point, I would probably, go ahead and combine like terms. Now, you don't have to, strictly speaking, but I do think it's going to make our lives a little easier. Well observed. And so I can go ahead and then combine the negative 10x and the negative 2x and make that into negative 12x. Now, strictly speaking, I didn't have to do that there. I could have gone ahead and just multiplied the parentheses at this point. If I multiplied these 4 by these 2, how many total terms will we get out? If you multiply 4 things by 2 things, what do you get? 8. So that would give us 8 terms if we multiplied them at that point. If I multiplied them at this point, how many terms would we expect to get out? Well, we're multiplying 3 terms by 2 terms, So yes, we'd be looking at 6 terms there. I prefer 6 terms than 8 terms. So that's why, yes, I would recommend that you go ahead and combine the like terms here. But if you want to wait to do that simplifying until the very end, you could choose to. All right, we got one last step here. Well, actually 2 last steps. We need to go ahead and multiply these parentheses out now. Because remember, when we do 2 times 3 times 4, I multiply 2 times 3 to get 6, but then I still have to multiply it by the 4 at the end. We got to do the same thing here. I got to multiply it by the x minus 3. But in this case, we're multiplying a trinomial by a binomial. How do we do it? Well, we still are going to multiply everything in the first parentheses by everything in the second parentheses. So for instance, this x squared, it's going to go to x, and it's going to go to the negative 3. The negative 12x is going to go to the x and to the negative 3. And the 20 is going to go to the x, and it's going to go to the negative 3. And again, when you do this multiplication, we should end up with 6 terms. That's the first thing that I want you checking after you multiply one of these big ones out. Make sure you have 6 terms, because that'll tell you if maybe you skipped something or missed something along the way. If you did this one correctly, this is what you should end up with. Now a little bit of color coding here so that we can see what multiplied to what. When we multiplied x squared in, we got that part. When we multiplied the negative 12x, we got those 2. And when we multiplied the 20, we got those 2. So if you didn't have something quite right or something missing, that can help you track down what happened. Now, we are finally at the last step. We have one more step to do. Even if you didn't choose to simplify at this point, and you had just multiplied out all 4 by both of them, yes, you could do that. And you'd end up with something that looks kind of like this, except there'd be 8 terms. But after you combine your like terms of that, you will still end up with the same thing as if you combine the like terms from this. And so we need to do that as our last step here, combine the like terms. And in this case, you'll notice that I have a couple of them that are x squared, and I've got a couple of them that are just plain old x. Those are the ones that I want to go ahead and combine. When we do that, this is your final answer. Now, throughout doing this whole process, we've had this little note up here. Notice that it says to always write your answer in standard form. Now, we'll get into standard form and some of the other details about it here in a little while. But basically, what standard form means is that you get rid of all the parentheses. Okay, so we did that by getting to here. You combine the like terms, which then got us here. And then the other little detail of it, which is different from just saying simplify, for instance, is that we do always need to put the biggest exponents first. So we're always going kind of in a decreasing order of the exponents. And you'll notice that that's what we did here, because we did the cubed, and then the squared, and then the 1, and then the constant term. And so that's how we want our answer to look. This would be the one right way to write this particular answer then. All right, so next up, this is going to be our last problem that we do together today. I'd like you to write this particular expression in standard form. Start by writing down the original expression. Now, in the last problem, we multiplied 3 binomials together. How many binomials am I multiplying in this case? 4. It kind of looks a lot like 3 binomials, but remember that x minus 2 squared is actually x minus 2 times x minus 2. So in this case, the very first thing I would do is actually write it out the long way there, because that's going to make it a little bit easier to see how to do this. Plus, it's also going to prevent you from falling into a potential trap, because I'll see a lot of people who will say that x minus 2 squared equals x squared minus 4. Or they'll say, oh no, that's wrong. It's x squared plus 4. No, that is also wrong. Because squaring, or any other exponent, does not distribute into a polynomial that way. And so instead of doing that, if I wanted to figure out what x minus 2 squared is, I would have to first write it like this, and then I have to multiply everything in the first parenthesis by everything in the second parenthesis. So by writing it out this way, it's going to help avoid that error. Now, let's talk strategy for this particular problem before you start actually working it through, because there's two main ways that people do it, and I think that one is probably preferable to the other, and I'd like you to be aware about both of them. The first strategy would be more the brute force kind of thing, where I could multiply those first two, and then once I find that, I could then multiply that by the next parenthesis, and then I could multiply that answer by our last parenthesis. That would work. But it is also a lot of work, and I think probably a little bit too much work. But because there are 4 sets of parentheses here, there's an alternative. I could multiply the first two together like that, just the same, but at the same time, I could also multiply the last two together, because then I could take those two results and combine those. I think that is preferable to the first. Now, you can do it either way, but I tell you, when I do it, I'm going to multiply them like this. So let's go ahead and do it this way. Please multiply those first two binomials and the last two binomials. And so when I first multiply them out, these are the two polynomials that we get out of that. But of course, if we just wrote it this way, it wouldn't be very good. We really need to keep track of the parentheses. So remember that since these will still be multiplied by each other, I still want to have parentheses around each of those. Now again, if we wanted to, we could go ahead and just multiply the two together at this point. I could now just go ahead and do that whole thing by that whole thing. But if I multiply the first 4 terms by the second 4 terms, how many total terms would we get? 16. That's a lot. And while we're going to end up with a lot of terms, it doesn't need to be quite that much. And so, as most of you probably did, I would go ahead and combine the like terms on both of these before going on and multiplying the 2 sets of parentheses together from this. So I would turn them into this. And now that we are here, now I can go ahead and multiply the first parenthesis by the second parenthesis, because there's only 2. But remember, I got to multiply everything in the first parenthesis by everything in the second parenthesis. That means I'm multiplying 3 things by 3 things. How many terms should I be getting out of this? 9. Yep. And use that as a way to check yourself. After you multiplied it out, make sure you have all 9 terms before you proceed. That way you know you got everything. All right, so when we multiply those through, this is what we end up with. Now I've color-coded it just so that if you have an error anywhere in there, this will help you find out where it came from. So like for instance, the x squared here gave me these 3 terms when I multiplied it through, all that kind of stuff. All right, now of course we're not totally done yet. We do have one last step here, and that is just combine the like terms. And so we start searching through. We got our x to the 4th at the start. By the way, a couple of you were saying, wait, how do we do x squared times x squared again? The rule there that we used was when you multiply the x's, you add their exponents. So we got the 4 because it was 2 plus 2. But you notice the x to the 4th, it's all by its lonesome over here. It doesn't have any other like terms. So that's going to stay in x to the 4th there. Then we come up against 8x cubed. It's got x cubed in it just like this one does. And so yes, we will be able to combine those. Just like I have 15x squared here, and I also have actually 2 other x squared terms, and our 60x can combine with 32x. Notice the 60 is also just going to stay as 60. It has no like terms with it either. And so when everything is then combined, this is where we should end. This is our final answer. This is simplified and in standard form. Again, reminding you, standard form here, remember, means in order from biggest exponent down to smallest as we take a look at the whole thing.